Ladies and gentlemen, this is the last module of the course, the conclusion. First, we will perform check for course objectives by review all the tools and techniques of Lean Six Sigma. Please pause the lecture and take all the required time to do the following. For each of the tools and techniques mentioned in the next slide, please perform the steps below. Mention the concept of the tool and technique. Determine when, where and how to apply the tool and technique. Mention advantage and limitation of each technique. Here are the tools and techniques to be reviewed. There are many additional applications of Lean Six Sigma in different sectors, such as financial sector. In recent years, finance and credit department are pressured to reduce cash collection cycle time and variation in collection performance to remain competitive. Typical Six Sigma projects in financial institutions include improving accuracy of allocation of cash to reduce bank charges, automatic payments, improving accuracy of reporting, reducing documentary credits defects, reducing check collection defects, and reducing variation in collector performance. Healthcare sector. Six Sigma principles and the healthcare sector are very well matched because of the healthcare nature of zero tolerance for mistakes and potential for reducing medical errors. Some of the successfully implemented Six Sigma projects include improving timely and accurate claims reimbursement, streamlining the process of healthcare delivery, and reducing the inventory of surgical equipment and related costs. Engineering and construction sector. Use Six Sigma program to identify and prevent rework and defects in everything from design to construction to on-time delivery of employee payroll. Research and development sector. The objectives of implementing Six Sigma in R&D organizations are to reduce cost, increase speed to market, and improve R&D processes. To measure the effectiveness of Six Sigma, organizations need to focus on data-driven reviews, improved project success rate, and integration of R&D into regular work processes. Academic sector. Many of the activities that go into providing an education are repeatable processes that can benefit from applying Six Sigma principles. Like Six Sigma, education is tightly focused on obtaining the voice of the customer, students, and improving the process to meet customer needs. This alignment of Six Sigma and education combines with a demand for greater efficiency, which is another trend that is reshaping every corner of the academic world. Supply chain sector. Lean and Six Sigma has been applied to improve the physical and information flow for both raw materials and finished goods. And in what extent implementation of this integrated approach will improve the supply chain processes in the terms of quality, delivery and speed, flexibility, and cost. Additional benefits of Lean Six Sigma. Your customers will stay loyal to you only when there is a high level of customer satisfaction for your products or services. According to latest reports, enterprises that use Six Sigma methodology achieve 40% more return of investment than enterprises that do not use this methodology. Six Sigma reduces the risk of having dissatisfied customers by identifying the root cause and addressing critical attributes of customers' perception of satisfaction towards their service product. Six Sigma can break any barriers and empower you to specifically measure time spent on activities and identify root causes of low productivity. By collecting business-critical data from various locations, Six Sigma will help you to address the real problem rather than beating around the bushes blindfold. With Six Sigma methodology in place, you can set up an exclusive team which has a mix of experienced professionals from all levels within the organization and from various departments. This team will then be tasked to identify critical factors that can negatively impact the project, which may lead to run beyond its deadline. In statistical terms, Six Sigma methodology reduces problems to 3.4 defects per million opportunities. As an organization, when you spend less time in fixing defective products, you will reduce the cost of achieving quality by 20% and increase the operating revenue by 50%. Lean Six Sigma may consider how their day-to-day practices are helping in their quest towards professional goals. With this kind of self-assessment, one will be able to create an action plan and work towards it to become more efficient and achieve proper work-life balance. Empower your employees with Six Sigma training will help them to learn new tools and techniques, which allows their professional development to create a favorable environment in an enterprise that leads to highly satisfied employees with increased motivation. Six Sigma is not just a process improvement methodology, it also plays an important role providing enterprise-level strategic planning. After your business has its mission statement and conducted SWOT analysis, then Six Sigma will help you to focus on areas for improvement. Now, we will discuss the benefits of Lean Six Sigma in your life and your career. Once you achieve Six Sigma certification, you will have thorough understanding of measuring and quantifying financial benefits. Six Sigma training makes you ready for leadership roles. There is no authorized organization that manages Lean Six Sigma certification process. The actual certification and training helps to achieve a culture for improvement. It also helps process management. Those who are aware and trained in Lean and Six Sigma voice a similar language. They better understand the steps need to be taken to fix a process and reduce wastes. As a conclusion, we can say that Lean Six Sigma is a method which provides prized analytic and process skills. These skills are relevant to leadership positions. Your Six Sigma certification will give you an advantage above the competition. It is a respected accumulation to your resume. You'll also improve upon problem solving. Lean Six Sigma provides benefits for individuals within the organization who become Lean Six Sigma leaders. The Lean Six Sigma methodology steers you through an organized process of inquiry, analysis, problem identification and solution creation. Many of the tools and techniques can be applied to everyday problems and issues. But even if you don't use all the tools, the organized problem-solving approach will put you in control of finding and fixing your problems. Interacting with team members and managers will likely improve your communication and decision-making skills. The structure of Lean Six Sigma can help you to develop your project management skills. And of course, being able to put on your resume that you led a project team that achieved cost savings, quality improvement, and cycle time reduction will only help you as you seek that next promotion or new opportunity. Attaining BELT certification is a valuable credential on your resume. Many job postings require that an applicant have a Lean Six Sigma credential. So, this will open the door for some promotions. Before finish the Lean Six Sigma course, you must understand and know the concept of Design for Six Sigma, DFSS, and DMADV model. The concept of Design for Six Sigma, DFSS, was coined by Motorola, who first applied it to the design and production of its pagers in the late 1980s. It goes beyond the current knowledge. It forces one to think of future designs. Design for Six Sigma is a proactive approach to eliminating problems from occurring. That is a design issue. Design for Lean Six Sigma model, DFSS, used to create major new features of existing products, services or processes, or to create entirely new products, services or processes. There are examples of the successful application of DFSS in 3 environments. 1. Business transactions and services. 2. Manufacturing processes and products. 3. Engineering products. In the service industries, DFSS methodology bypasses the measure and analyze phases of DMAIC by creating a process that prevents the variations from emerging. This prevention methodology moves the 5 Sigma performances to yield 6 Sigma results. In manufacturing processes and products, DFSS encompasses the methodology of QFD, quality function deployment, and gets the designers and contractors working in concert to optimize the capability of the manufacturing process to obtain a consistent quality for the product. With regard to engineering products, in addition to applying the principles of concurrent engineering, which entails the development of both products and processes, DFSS uses DOE for design optimization. The DMADV model is the Design for Lean Six Sigma model, DFSS. It has 5 phases: define, measure, analyze, design, and verify or validate. The define phase of the DMADV model has 5 components: establishing the background and business case, assessing the risks and benefits of the project, forming the team, developing the project plan, writing the project objective. The measure phase of a Design for Lean Six Sigma project has 4 steps: segmenting the market, designing and conducting a survey of stakeholder segments, using the survey results as quality function deployment inputs, QFD. Identify CTQ variables and technical specifications. The most common and effective technique at this stage is QFD. QFD is a method team members can use to understand the relationships between the needs and wants of stakeholders and the features of the product, service, or process design. The analyze phase contains 4 steps: design generation, design analysis, risk analysis, model design. The key tasks of this phase include: formulate conceptual design, identify potential risks by using FMEA, use DOE to determine CTQs and their influence on the technical requirements, develop a bill of materials, formulation and procurement plans, outline a manufacturing plan. DOE and FMEA are the most appropriate techniques for the design phase. The design phase of a Design for Lean Six Sigma project has 4 steps: constructing a detailed design of the best design from the analyze phase, developing and estimating the capabilities of the specific features, for example, size and brand of a refrigerator, called critical to process, CTPs, elements, in the design. Use simulation to predict and design for robust performance. Preparing a verification plan to enable a smooth transition among all affected departments. Implement design, commission and start up. Verify or validate phase. The intent of the verify-validate phase is to facilitate buy-in of process owners to design a control and transition plan and to conclude the DMADV project. The process owners and all stakeholders were kept intimately involved in the project. A summarized checklist of the findings of this project was developed and should serve as a guide for the engineers who will further develop the project. Additionally, a preventive maintenance system, per manufacturer recommendations, must be implemented. Occupancy indicator control charts must also be implemented. The final part of the verify phase is to maintain communication between the champion and the process owner. These lines of communication will alleviate any confusion or other unforeseen problems that will inevitably develop. It will ensure that the conceptual design is not compromised by outside forces and neglect. To choose between DMADV and DMANIC, ask the question, does the process exist or not yet? DMANIC addresses the current process, while DMADV addresses the design process. DMANIC reduces or eliminates defects, it is reactive action, while DMADV prevents defects, it is proactive action. DMANIC includes specific solutions, but DMADV is part of the solution design process. DMANIC includes controls to sustain the gains, and DMADV includes verification and validation of the finished design. It is time to upload your project. The project outputs should include the following. Complete report in PDF format includes the following. Location, steps and objectives of your project. Problem statement, goals, project charter, etc. The report also should include all the information about the manufacturing process of your project, with photos and their details. Using tools from the defined phase, Kano model, CTQ, etc. The data collection plan, measurements tools analysis, etc. Analysis of the collected data and process metrics. Using techniques from the measure phase, Pareto analysis, gauge R&R, value stream maps, etc. All tools used to analyze the data collected in the measure phase, hypothesis tests, transforming data, ANOVA, DOE, C&E matrix. Work done in the improve phase. Using tools in improve phase, setup reduction, change to pull system, implementing 5S, process balancing, failure mode and effects analysis, etc. Control charts for all the important data, before and after project implementation. Value stream map, before and after project implementation. All use tools in the control phase, standardization, reaction plan, etc. Closure in future work, to gain more improvement, for the selected manufacturing area. The project outputs should also include the following. All the diagrams, figures and photos, for the process and work done. All the tables used in any step of the Lean Six Sigma project. All the files generated from any used software, such as Excel, Sigma Excel, and Minitab. Please upload these outputs in a folder with your name, to the following link of the Dropbox. The following steps will be done, in order to assessment your work. All the received emails, for the activities outputs, will be checked, and feedback will be sent to you. Your uploaded project report and outputs will be evaluated. Complete feedback with detailed comments will be sent to you. If any additional requirements are needed from your side, an email will be sent to you. After receiving the additional requirements and making the necessary evaluation for your work, the Six Sigma Black Belt certificate will be sent to you via email. With this module, we come to the end of the Lean Six Sigma Black Belt for Manufacturing Industry Professionals course from Productive Quality Institute. We wish you a great journey of excellence. Thank you.